Dear students, let us start again our interaction on the intersection layouts. In the previous interaction, we discussed about the attributes which are required to be taken care of in the design of an intersection, where we talked about design speed, design vehicle, turning radius, etc. And then after that, we discussed about the various factors which influences the layout designs, and they were related to human beings, traffic, roads, environment and economics. We thought of discussing about the auxiliary lanes, but we could not do that, and so in this interaction we are going to start with the auxiliary lanes, and then we will move to the speed change lanes and finally to the channelization and see that how much we can cover in all of these three aspects. Let us start with the auxiliary lanes first. Now, these auxiliary lanes, from the name itself, defines that they are specific lanes which are being provided as an additional feature at an intersection. And when we are looking at these things, they can be of three types, and they are defined as storage lanes, they are defined as the right turning lanes, and they are also defined as the speed change lanes, which can be the deceleration lane or the acceleration lane. So, we will be discussing about all of these three type of categories one by one. The objective of providing these additional lanes at any of the intersection is to improve upon the efficiency as well as the safety of different type of movements which are taking place at that intersection. So, when we have this sort of a segregation by these lanes of the traffic which is going to take different type of maneuvers, basically we are helping them in terms of achieving the capacity and improving upon the conditions at that particular intersection. So, these becomes the features due to which these type of lanes needs to be provided. But when we are looking at these lanes, when we say we have a storage lane, so there is some lane being provided and there are vehicles which are moving in this lane. So, how many vehicles can come in that particular storage lane? When we say storage lane, say there is a stop line here, then how many vehicles will be there in this particular lane, and as soon as the opportunity is there to move ahead, they will start moving. So, length of the lane is one thing, and another thing is what is going to be the width of the lane. Most of the time we go with the 3.5 meters wide lane, which we have discussed from the very starting in the normal conditions. Of course, on an expressways we said that it can be 3.75 meters, or a single lane roads also it is different. So, the first case is a storage lane, and along with that we are also talking about the right turning lanes. Now, what happens is that when you are at an intersection, whatever the intersection is there, at this intersection the traffic is going straight, but then there is a traffic which is interested to take a right turn, and when this traffic takes a right turn, then this is the trajectory which it is going to take. Now, if we ask this vehicle to stop here and we have these two lanes and there is a median at this point, so what will happen is there is going to be a queue formation, and this is not good for the efficiency of this particular intersection. And this is the reason we need to look at that what should be done so that this right turning traffic, when it stops here and looking at an opportunity, because there is a traffic which is coming in this direction also. So, this is going to create some impact here in terms of a conflict point. So, can we omit that? What type of design feature needs to be included? What type of changes needs to be done in this intersection area? But then this is not going to happen in each and every case. It all depends upon that how much is the amount of this turning traffic. So, if this turning traffic is quite high, now when we say it is quite high, then what is the value is not known here, and generally we consider that if it is somewhere around 30% of the traffic which is coming on this approach, then we should have the right turning lane. And when we are providing this right turning lane, then there is also a through lane just adjacent of that, in which the traffic is waiting to go ahead if the opportunity is being provided. So, you have a traffic which is standing here and this is desiring to go straight. So, this one is a through lane and this becomes a right turning lane. So, in the form of a design, if we look at, it is going to be a bit different. So, when we look at that and we have a median, then this is how it is going to happen. So, we had the through lanes here, this is a median being provided. So, we are providing the opportunity for the through lanes and the through traffic to keep going ahead, but then there is a movement for the right turning and the right turning traffic comes here and waits on this particular lane. So, now what happened is whatever the queue formation is there, that is in this right turning lane. So, it is not creating any effect to the capacity of the through lanes. So, we can have these as through lanes. Now, what should be the length of this storage lane? So, when we say that's length, then this is going to be the length which we are talking about. Now, it all depends upon that how many vehicles are going to stop in this particular lane for taking a turn at any point of a time. So, that means we have to consider what total number of vehicles are there, what is the gap which they are maintaining, the length of those different type of vehicles along with the taper being provided here will define that how much is this length. And it can be considered as a thumb rule as 1.5 times the average number of vehicles by type expected to use the lane during the peak hour. So, during the peak hours whatever total number of vehicles are going to be there who are expected to take a turn, let us count those, and then on the basis of that we have the lengths also. So, number n multiplied by the length I of a category of vehicle plus if we are talking about some gap, then that can be there for source to take this particular gap, this 1.5 is being considered here as increasing that length, and that is how we are going to get the total length of the storage lane. Here you can see some examples being given. What you found is that there is a 4 lane divided system. So, we have 2 lanes here, we have 2 lanes here, but when we are going ahead, so that the traffic here is moving in this direction. So, this traffic can keep moving in those 2 lanes, but when we are coming to an intersection moving in the direction towards the intersection, we have done a segregation of a left turning as well as a right turning. So, this is a right turning and this is a left turning condition being created, and there is a channelizing island being provided here, and there are pavement markings being placed on this side. So, that is how the segregations have been achieved, all rest of the markings remain the same. So, what we need to do is a flaring of this particular section at this point from a 2 lane to something like a 6 lane system. Now, if this type of a design is being provided, it is quite a good design. The another design can be that what we have done is that this aisle this particular marking area which should not be used by the vehicles has been increased in size, and this has been further utilized by reducing its size so as to create a lane for the right turning. But then in the first case what you can find is that the length of that transition which was there in terms of the number of lanes which have been depicted by way of the markings on the pavement has been stopped before this change in the profile has started. But in this case what is happening is that it is going beyond. So, this becomes a bit satisfactory rather than quite a good design in the case of other one. The other case is that instead of having this island being shortened like this, now in this case it has been increased in size. But the problem here is that this creates a restricted movements, and if the traffic volume is quite high, then this is going to create a problem in terms of the queuing at this location. So, this is satisfactory, but it is not such a good design, and therefore, we should try to omit this, or we should try to reduce the size of this island which is being provided here as a divisional island to a shorter one, and that is how this restricted condition can be improved. Now, let us examine these cases. Now, in these particular cases again we have island here. So, here also there is an island, but the issue is the size of the island in terms of its length. Here this has stopped here, whereas the transition is starting from this point. Here also the transition is starting, and at the same time we have the island also. And then these markings in front of the nose of the islands, they are moving inside, this particular area. So, from where the further transition has taken place or that has started. So, here again in terms of the movement, in terms of the ease of driving, the steering of vehicle and taking the different lanes as being demarcated for different movements, this becomes easier as compared to the another case. There is another example here where again from a 4-lane system it has been transformed into say a 5-lane system, where one lane is being given for a through lane, one for the through as well as a left turning, and one is an exclusive right turning. But flaring is always going to be there in all of these cases, as you can see. Here again the size of the marking and the size of the island matters, and as soon as you start increasing the size of the islands toward the restricted conditions, it becomes a satisfactory design or unsatisfactory design, because you have to take care of the movements of the vehicles, which should be done in a more easier manner without having a psychological feeling of the restrictions being imposed. Now, in many of the cases it may be observed that there are not many vehicles which are going to be there in a storage lane. Say if there are not more than 1 or 2 vehicles which are expected to stop, then the length of the storage lane should be how much, and that is what is being defined here. With respect to the design speed of 50 kilometers per hour to 120 kilometers per hour, the length of the storage lanes has been shown as 90 meters to 200 meters. And when we are talking about this storage lane, as I said that it is going to have a taper and then this type of a situation. So, that is the total length which we are looking at. So, including taper of 30 to 45 meters is what we are talking. So, that means this is 30 to 45 meters. Now, let us assume that we have this particular lane which is being utilized for right turning. So, if this lane is 3 meters wide at a minimum, then that means this flared section is going to have 1 in 10 to 1 in 15 as a rate of taper. So, that is going to be the minimum value which can be there. So, as 1 in 10 is usually being considered as one of the minimum values here. In normal conditions, we will be talking about the transitions and where we discussed about these things in the medians etc., and that was 1 in 15 to 1 in 20, but on an expressways it was 1 in 50. So, here again we have the same case where we are going to provide a transition from one section to another section, and that is where the transition curve has been utilized here. So, there is a transition curve on this side or a transition curve on another side with a straight section in between. Now, depending on that what is going to be the width of the lane, whether it is 3 meters wide or more than 3 meters wide going up to 3.5, the length has been defined here, and this length of the storage lane can be 60 meters to 65 meters and corresponding to 3 meters to 3.5 meters of the width of the lane. The basic change is going to be in the central portion, the rest of the things are going to be more or less constant. Here there is an example being given, and we have to find out what is going to be the length of the right turning lane as well as the length of the through lane when some information has been given to us. The very first thing is that we are talking about one right turning lane and there are 2 through lanes as being talked here. Then at this particular intersection the signal has been provided and the cycle time C is 90 seconds. Now, the traffic count has been done and it has been found that the right turning volume at the design peak hour is 150 vehicles. So, it is 150 vehicles per hour and the composition is 10% of trucks, and the through traffic was found to be 520 vehicles per hour with 15% of trucks. Let us assume the average length of the cars is 44.5 meters and the truck is 11 meters. So, that means there are only 2 type of vehicles on this particular intersection, cars and trucks. The composition in terms of trucks has been given, therefore, the rest of the things are car only. Now, we have to calculate what should be the length which needs to be provided here. Now, when we look at 1 hour, so in 1 hour we have how many number of cycles which are there. So, number of cycles can be found out. So, one cycle length is 90 seconds. So, accordingly the number of cycles comes out to be 40. So, there are 40 such events in which these type of turning movements are going to be there. But when we look at the traffic, traffic has been given for 1 hour. So, we have a right turning traffic which is 150 vehicles per hour. So, therefore, for one particular such number of cycle we have only 4 vehicles which are going to take a right turn. Similarly, when we talk about the through vehicles, then the through vehicles again the value is being given as 520 vehicles per hour. So, divided by 40, and then as we have 2 through lanes. So, it is being divided by 2. So, it becomes per through lane. So, now we have got the values. So, we have 4 vehicles in the right turning and 7 vehicles in the through lane. Now, we use the composition. So, there are 10% trucks in one case and there are 15% trucks in the other case, and the lengths are also being given to us. So, the length of the right turning lane is 4 multiplied by 0.9, 90% of cars. So, length of the car is 4.5 meters. So, this is percent composition and this is the length of vehicle. Similarly, 10% are trucks which are 11 meters in length. So, what we get is 20.6 meters. If you look at through lane, so out of 7, 15% were trucks and 85% are cars. So, what we get is 38.25 meters. So, whatever is the bigger value, let us consider that and make it rounded off. So, we are going for a storage lane of 40 meters which is 3 meters wide, and if we are considering a 1 in 20 as a transition, then it becomes 60 meters. So, that means now we have a total length as in this form. So, this is going to be 60 meters and then 40 meters. So, total length is going to be provided in this form. Now, one other thing which is being added here is a clearance of minimum 3 meters in front of the island for smooth turning of the vehicles, and this one particular value I am going to discuss further when we will take up the channelization. So, let us keep in mind that this is one thing which is being left and we will talk about it. Now, let us look at the speed change lanes. So, in the case of speed change lanes, these are usually required in the rural areas where the traffic is going to get out of the system or get into the high speed system, and therefore, there is a requirement of changing the speed from high to low and low to high. So, it is a thing which is mostly being provided in the rural highways conditions or in the multi-lane highways or on the exits or entrances to the expressways. So, one such sketch is being shown here. Now, what you can see here is that there is a traffic which is coming from this side. This is moving with the design speed. Now, there is some traffic which keeps moving with the design speed, but there is another traffic which is taking a turn, and when it is taking a turn, then it is going to reduce the speed and it keeps going and it keeps reducing the speed from T1 to T2, and then it takes a turn and again it is going to increase the speed. So, when this type of a thing is happening, that means there is a deceleration taking place on this side. Similarly, when we talk about a vehicle which is coming from this direction and it is getting the turn and goes here. So, it will be coming with the reduced speed and then it is going to be on a higher speed V1, and finally, when it gets into the system as a through lane, then in that through lane it is again going to move at a speed which is a design speed. So, there is again a transformation of the speed from a smaller value to a higher value. The same thing may happen that the vehicles which are coming with the design speed takes a turn and therefore, now they are having a right turning speed and they may come to a stop at this location, and when the opportunity is there, then they will move and take a right turn. So, there again we are going to have this type of a speed change condition. So, these acceleration lanes, deceleration lanes, they are actually the speed change lanes. Now, what additionally you can see here is that there is a right turning being provided here and we discussed about it already. There are islands being provided here, there is a median provided on this side, there is another island which is there which is a divisional island being provided. So, directional islands, divisional islands, medians, markings, all together defining in what particular fashion the driver should move on this particular intersection. Now, let us talk about these speed change lanes as acceleration lane and deceleration lane. Now, acceleration lanes, these allows the vehicles which are taking left turn to join the main highway and at a particular speed which is the speed of the main highway. So, that means they are taking a turn at something like 40 or 50 kilometers per hour and then trying to reach 100 kilometers per hour and then joins into the mainstream. Now, when they are going to join and when they are going into the acceleration lane, that at that point of a time a setback of 5.4 meters is being provided at the tangent point of the turning curve. So, if we are talking about this turning curve, so here at this point we are talking about the 5.4 meters. And the same thing is in terms of a deceleration lane at the start of this turning, this is 5.4 meters. But when we look at the back, it reduces to 4.25 and at the back again when you are going in this direction, it is further increasing. So, that now it is giving an opening. So, first of all a restrictive condition and then an opening condition to start increasing the speed and go ahead. The same is happening here, this is 4.5, 4.25 and then 5.4. So, that is what is being said, the reduce the lane width from 4.5 meters at the start to 4.25 meters at the end before turning, and just after this turning when they are going into the main highway, they are going parallel to that, then it is 5.4 meters. And the edges needs to be marked clearly. We have discussed about the edge markings and this is 150 mm wide at a setback of 100 mm from the curb. Now, provisions needs to be made in terms of the chevrons at the nose of the island. So, whatever islands are there. So, if we are talking about a turning in this form, so there is going to be the edge marking in this way. So, this is going in the and therefore, the chevrons are going to be placed here. So, this is our island. So, provision of chevrons are going to be there at the nose. So, that creates a path. So, this vehicle goes in this direction and they are segregated out, and after they reach a certain distance by which they have a mutual visibility, then they have an option to mix. These are recommended if the future traffic on the acceleration lane is expected to be more than 1000 PCUs per day. So, that is a guidelines when we should go for the provision of these type of lanes. Length is considered from the nose tip of the channelizing island towards the exit. So, this is the nose tip. From here what will happen is that we are going to provide like this and then this and this. So, this is the length we are talking at the acceleration length. When acceleration lanes are being provided on a gradient, then in that case for a down gradient it specifies that the length may be reduced by a factor 1 minus 0.08 g, where g is actually the gradient and this gradient is in percentage, 1% gradient, 2% gradient and so on. So, that is the value which we are considering. So, if it is 1%, it means it is 1 minus 0.08. So, we have 0.92 times of the length which otherwise we have calculated. Here this particular table provides the tentative values which can be provided. So, it talks about the design speed as well as it talks about the speed with which the traffic is reaching that location where now the acceleration is going to be there. So, not necessarily the vehicles are moving at the same design speed. So, against the 100 kilometers per hour of the design speed, there is a possibility that the vehicles are coming at a speed of 75 kilometers per hour. Now, similarly, the traffic which is coming from the side road and is trying to mix by accelerating, for that the conditions have been given. So, at an entrance curve, what is the design speed? The design speed can be 25 to 80 kilometers per hour, depending on how good, how flat that curve is being designed, and it may be that the vehicle is in a stopped condition and then it starts moving. But then again this may not be true, and therefore, the initial speeds have been considered which are bit lesser than the design speeds, and that is the value being given here. So, for a combination of say 75 kilometers per hour as an approach speed at which the traffic is continuously moving on a main highway, and we have a condition where the initial speed is 40 kilometers per hour, then for that the length of this acceleration lane is going to be 280 meters, and that is the how we are going to find out the values from this chart. Now, let us look at the deceleration lane. Now, these deceleration lanes, these are provided where the traffic is going to just come out of the highway and getting to take a turn to the other lane. So, it is desiring to leave the major highway. So, they have to slow down, but if they are slowing down in the through lane, then it is going to create an effect to the capacity of that lane, and that is where there is a requirement of provision of a deceleration lane. Now, these deceleration lanes are provided on the left turning traffic on the near side of it, and if you are talking in the center of the road, then it is in the case of a right turning traffic, and we have looked at that particular design. Now, in the case of near side deceleration lanes for the left turning, so you are coming from a through traffic, you take a turn, goes into it and then take a left turn. So, this is what we are talking. The length should be such that it allows vehicle to slow down from a speed on the major road, which is Vd to V turning, to a speed that is safe enough to negotiate the turning curve. The turning speed should be 30 to 40 kilometers per hour at least. Usually that we should talk about this at the minimum level. And another thing, as the same way as in the case of acceleration lane, it defines when it is warranted to provide that lane. Here also it says that if the traffic which is going to take this particular turn is more than 750 PCUs per day, then we should provide this deceleration lane. Now, right turn deceleration lanes in the central medians, they should be provided for all gaps on the dual carriageway roads. If there is a 3-lane road, then the central lane should be marked for right turning, where the product of estimated future cutting flow is more than 1 million PCUs per day. So, when you are on this case of the right turning condition here, then there is going to be a traffic coming from here, whereas we are talking about the turning in this form, and there is a traffic which is going to turn in this way also. So, there are different type of traffics which are going to be there. So, we have V1, V2, V3, and that is what the cutting traffics which is going to be there. So, those cutting traffic, the product of that, if it is more than 1 million PCU per day, then the central lane is going to be considered as a right turning deceleration lane. Now, provisions may also be made for roads with lesser flows, but with road user crash records, thus warranting the provision. So, if the road is not of that high quality, is not having that amount of flow, but there are a lot many crashes, and the type of crashes have been identified in terms of those turning and side sweeps, etc., then we should go for it. Or in the case of 2-lane roads, where the changes can be incorporated in the realignment. Then in the case of overloaded 3-lane roads, or where the junction is at crest, the dual carriageway shall be provided for short lanes, and deceleration lanes may be used for right turning traffic. So, it is trying to give you more and more information that what are the various situations which can be there, and considering those situations, examine the cases and see that whether there is a requirement of providing that or not. Here again, if there is a gradient, then for that gradient it tries to specify that whether to increase or decrease the length. So, it says that on an upgrade, the length may be reduced by multiplying factor of 1 minus 0.03 g, whereas on a downgrade it can be increased by a multiplying factor of 1 plus 0.06 g, where again the g is the gradient which is being taken as percent form. Now, the median is to be shortened at the right turning point, and this is set back by 3 meters from the tangent of a crossroad. This is the same thing, as I said, we are going to discuss further. So, I will show you in one of the diagrams further at some point. The right turning deceleration lane should not be less than 3 meters wide. It should remain parallel with the entry and should have a return radius of 180 meters with a taper of 30 to 45 meters. So, we have already discussed about these things. This table again gives us an idea, and the idea is in the same form as we have discussed about the acceleration lane. So, we have design speed, we have the running speed, we have the speed at the exit curve, but then the average running speed at the exit curve is also there, and based on these combinations we can find out that what should be the length of the deceleration lane that should be provided anywhere. So, this chart is going to give us that idea. So, we can now stop our interaction here, and we will be going to discuss about the channelizations in our next interaction. So, till then you can wait for this particular interaction, and we will be continuing with our rest of the other things too along with those. Till then, thank you and goodbye.